Good morning, my name is Alberto Lavelli. I'm a senior researcher at the Fondazione Bruno Kessler in Trento, Italy. And my area of expertise is the application of natural language processing techniques in general to text, but in this case in particular we work in the natural language processing work package of the IDEA4RC project. Okay, you have already seen Unai. Okay, so the recap is okay. I can skip it. Okay, so now I'll explain what we have done for exploiting large language models for extraction of unstructured information in multiple languages. In this moment, we are working on Polish, because this is the available data, but we plan to work in Italian, Swedish, and perhaps also Spanish. And then, okay, this is the first part. I will deliver by me, and then Unai will deliver the part on NLP-Powered cohort building. Okay. This is the starting point. The starting point is that we have the annotation is performed by clinicians using the cleaning out tool. And the cleaning out tool produces 4 different files, JSON files, and we have to put together the information in order to have a single file containing all the information that, and also not only putting together the information, but also correcting some inconsistencies, some problems with the selections of the annotations and the highlights in the text. This, as for simplifying the work, having a language agnostic format, simpler to understand and manage, and also easier to when we need to perform fine-tuning over our NLP models. So this is a very technical issue, but it's important because it's the starting point for applying our large language models. This is an example just to give you an idea, and the relevant points are the highlights, when there is the highlight as it is in the note, and the highlight corrected because there was a problem with the selection of the highlight, and the annotation, so the variable in the data model that is used for identifying this case, this data point in the file. Okay, some statistics concerning the data set of which we are currently using. So the MSCI data set, we have 133 patients and 5,050 notes with annotation and highlights. This is in a sense, is the structure of the prompt we are building to interact with the large language model. The first part is the description, the general description of the task that we want to perform. The second part is the instruction, so we are more in detail, we specify what we ask the large language models to do. The third point is the this definition of the output that the large language models have to produce so that it can be exploited by the later stages. Then there are some examples in the case when we have a few shot, when we apply few shot technique, we have the examples, or in the case we will see that there is also a possibility of using RAG-based selection, and then the input and the output. So this is in the case of when we have when we train the model, the input and the response, so the annotation that we need to produce. Okay, as I said, there are two possibilities. One, producing few shot, so providing the model with some examples, and all the other possibilities to have a RAG-based simple example prompt. There is a trade-off between the fact that with the few shot we have problems with long text. When we have long notes, there is an issue with there is a limit to the capacity of the model to perform its job, and if to prevent content overflow and retain the old text, we adopt the RAG-based solution, and the performance is lower than in the previous case. So there is a trade-off between the length and the performance. And these are some experiments. I reported some experiments performed. I forgot to mention the fact that we are using Llama 2 and Llama 3 as large language models. And in particular, in this case, we are using Llama 3.1, 8 billion instruct. And these are some experiments that shows the fact that providing the highlights helps the algorithm to obtain better results. And then I have some examples concerning some specific parts of the data model. So in the case we are interested in information connected to surgery, we have these data definitions that are considered as to identify relevant information, in this case the day and the result of the surgery. And also here there are some examples in different with different settings, where we can see that when we truncate the length of the note, there is an increase, a slight increase in performance. Another similar experiment was performed for radiotherapy and chemotherapy. These are the surgery and radiotherapy and chemotherapy are the two areas of the data model where we focus more in this first part of our experiments. These are some remarks and open issues concerning the situation of the of the what we have done so far for extracting information using large language models. There are some issues, as you imagine, with privacy, so we have can be forced to use less powerful hardware because of privacy issues, and so this has an impact more or less on the performance. Till now we have performed experiments only on the Polish data, but the Swedish and Italian data will be available soon, so we are confident that what we have done so far can be ported to the new languages with only minor issues, but I mean, we are confident and we will see soon. And then there is, as I mentioned before, an issue with the length of the nodes that may have an impact on the performance of both of fine-tuning and of few short experiments. And also there is one other issue is that sometimes there can be sparsity of data, so this can be for some categories we may have not so many examples, and so this can be problematic because the algorithms need to have examples to learn how to find the information, and for some of the categories this could be problematic. Okay. Now I will leave the floor to Unai again.
Thank you. Hello again. So I will talk a little bit about slides prototype we got for building course through NLP. So Alberto showed this part where we applied NLP to get information coming from the EHRs and the free texts in the different hospitals. So now I will talk about this kind of idea where we want to build cohorts using natural language processing just to ease the process of getting data, right? So the main problem here is that extracting a patient cohort is really difficult. Probably those of you that have tried already know. Okay, so there are many challenges. Few of them are you probably need SQL expertise. So many times you need to ask the data manager to help you. You need to know where to look for the data, which databases. Then you need to know which fields, tables, etc. Then, of course, the second problem again is the vocabulary knowledge, right? So many times we may use some codes in our EHR systems. We also need to identify those, okay? And this is also challenging for the NLP. We need to know what are we looking for, okay? Third, we need interdisciplinary work. So usually when you want to do a study, you need a clinician who asks the research question, then you may have a little team just to discuss some of the things, statisticians, data scientists, then the data managers and so on. So this is a really difficult and complex work. And finally, of course, we need to spend time on it, right? So all these meetings, all this process takes long, and we are spending a lot of effort getting the data, right? So the idea is, again, as I said, yes, we will leverage natural language processing and large language models in this case to make the data retrieval easier, okay? Okay, so what we did, okay, we created a pipeline that has three main features, let's say. So the first one is the semantic discovery steps. So you will see afterwards, we just write a core criteria. Okay, so let's suppose we are looking for female patients that had a specific type of cancer and went under 2 surgeries, okay? What we do is we try to identify the entities or the terms that are relevant from the clinical point of view, and then we discover them. We have this file where we can identify the codes, right? So then, once we understood what we are looking for, and we got the codes for this, what we do is send that like refined version of the text that the user entered in a UI to a large language model. So the large language model, we are currently using a 7 billion large language model, which is not too big, and it is derived from Llama 3.1, and it's trained for SQL. So the idea is I send this refined version of the text, the large language model understands it, and then it reports the SQL query that we need to perform against our database. So there, of course, we get the SQL and then we execute it, right? So the process is kind of automatic. So you just enter your text, your Cohort, okay, as I said. Then you need to validate a few codes, a few concepts that you may find in the text, and then you click on a button and the process starts. So the LLM gets SQL and is executed against the database, right? So this is the example, and it is the one that I said. I think so. Female patients diagnosed with head and neck cancer who went undergo surgeries, right? So if you think about this, it's a relatively simple Cohort, but it's not that easy to do straightforward. Okay. So you see, first things first, we identify, as I said, we identify the most important entities. Okay. So here we can remark 3 entities which are female patients. Okay. So we need to look for female patients. Second, diagnosed with head and neck cancer, right? So we need to know all the conditions that include head and neck cancers, and this may be really difficult. And finally, we need to identify 2 surgeries, right? So here what we do is we have this kind of semantic interoperable layer that basically what it does is it understands the entities and then gets the female codes, okay, that you may use in a database. We did this for the IDEA4RC project, and we have all the codes. We have the female codes, we know where to look for them, and also we have all the codes for head and neck cancer. Okay, but the idea is that this is extendable for any kind of data model, right? And here, what you see is like the refined version of this query. Okay, so you are the user, you enter this, and there is some steps behind it where we identify the female codes and put them there. Then we identify the head and neck cancer codes and put them there. Okay, so you can imagine this is a huge list with many codes. Okay, and then we identify this entity with this surgery. Okay, and we also have these surgery codes. Okay, so this goes into the large language model, and the large language model understands how to convert this into an SQL query. Okay, and this SQL query then is executed against the database. Yeah, so this is a step. Then these codes go into the large language model. Then we go into the databases of the hospital, and then we get the data back. Okay, we can get it in Excel format, whatever, CSV, whatever you want. Okay, so this is the approach. Okay, so here I have a picture, okay, of the UI. I couldn't add the video, but if anybody is interested in this, just ask me afterwards. We can show you the demo. So the idea is quite easy. You will see here there is a text box. So the user enters there the text, the code he or she wants to get. Then you need to hit on this button, process text. You will validate the codes that we identify, and then you just click on another button and you get the automatic result. Okay. So this is what we did for natural language processing and code building. And I think that's everything from my side.